So I believe the first key benefit of powder metallurgy and powder technologies at large is net shape capability. And this as a consequence of allowing to use less raw material, to have less machining, less metal removal, so less chips, less waste, and less energy needed for the machining, and also reducing the number of assembly operations, which is bringing various advantages for the powder metallurgy. Of course, cost advantage, but also lead time advantage, and third, environmental advantage. Basically, with the net shape process, you will, in one step or fewer steps, create a complex metal part compared with conventional route, where you will, from a block of metal, machine complex shape. A very important benefit of the powder technology is freedom in design, which is allowed with a net shape capability. This freedom in design is particularly important with additive technologies and 3D printing. And thanks to the unique shapes which you can create with these technologies, you can thus imagine parts which are lighter, or create designs which are impossible to machine. For instance, internal cooling channels, or complex lattice structures, or honeycomb structures, which are impossible to create in other ways. The freedom in design is very important, both to reduce the weight and size of parts, and this is very important in various industries to reduce energy consumption, for instance, in aerospace. Powder technology really opened the door to very innovative material possibilities in the field of metallurgy. By starting with metal powders, we can have a more creative approach of materials, and in particular we can, with powder metallurgy, create alloys which are impossible to cast and forge. You can also create metal matrix composites or functional materials which are difficult to obtain with other metallurgy technologies. I personally believe that powder metallurgy should be in reality named power metallurgy because it is faster, shorter cycle time, greener, you use less energy than with other processes, you reduce raw material consumption, and also it's cost efficient. The future of powder metallurgy, first I would like to start reminding that powder metallurgy has been used since long in the field of automotive industry, both for PM components, press and sintered for instance, but also with PM tools that are used for metalworking or plastic processing, and these are tools from the HIP, hot isostatic pressing technology. For the future, I believe the growth will come primarily from the energy and aerospace sectors. For various powder metallurgy technologies, which include, of course, hot isostatic pressing, but also metal injection molding and additive manufacturing more recently. The reason for it is the possibilities of designing lightweight components and enhancing the performance of materials so that they are they have a higher temperature resistance, for instance, which is very important to improve the energy efficiency, both in various energy-related industries and aerospace.